In today's video, we're going to be talking about what it means for a function to be continuous and looking at that relationship with the limit of a function. A function is considered continuous when it has no breaks of any kind. If you could sketch the graph of a function without ever needing to lift your pencil, then that function is continuous, which is one way to think about it. Now, in terms of limits, as x approaches an x value, which we will call c, the function must also approach f of c since it's continuous, meaning since it has no breaks of any kind. It's just smooth and flowing. So a function f of x is continuous when the limit of f of x as x approaches c is equivalent to f of c, aka when the limit equals the function value. We know from our previous limits video that this is not always the case, and when this is not the case, then we know that the function isn't continuous. The left graph is an example of a continuous function, and the right graph is an example of a non-continuous function. Let's say we want to state the intervals of continuity, aka it's asking us to state where is the function continuous. Well, we can look at f of x equals 3 divided by x minus 5. Something right off the bat that we want to note that we know it's not going to be continuous where the denominator is equivalent to 0. And from there, we can say that it's not continuous at x equals 5 because at x equals 5, the function is not defined. And if we want to state into further terms, it's not defined because this creates a vertical asymptote at x equals 5. So we know that it is not continuous at x equals 5. And that's the only place where it's not continuous. Everywhere else it is. So this is our interval of continuity. And this is the graph. As you can see, there's a vertical asymptote as x equals 5, so therefore it's not continuous. Now we have this following function. Of course, we know that it's not continuous where d equals 0. After factoring out the denominator, we can see that it will not be continuous at x equals negative 3 and x equals 3 because the function isn't defined there. And from there, we can state the intervals of continuity, which is the following. Now, another way you can actually approach this problem is by simplifying both the numerator and denominator, and you can see that they're going to have a common factor and then cancel those out. But the intervals of continuity is still the same because even when a hole occurs in a graph, that function is still not considered continuous because the function isn't defined at that hole. I hope this video helped. Comment down below any other math topics for me to review. Thank you.